In this topic, we're going to discuss long-running processes or long-running applications in Azure. And it probably makes sense to first take a step back and say, what is a long-running application? What does that mean? Everything's long-running. Well, not really. So the primary use case for what these are service-type applications. One could argue that a web server is a long-running application because it doesn't end, but until we restart the web server. But most of these are service-based applications that we have on premises existing, and we need to be able to port these to the cloud. And so really what we do is we say, okay, if we have a Windows service-based application and we want to run in the cloud, what are our targets? And worker role is one that was defined to actually fill this void. Now we have two different ways now. So we have the worker role that we can run, and we also have the web app model that we talked about. And the web app model is a lighter weight model, so we can run these things called jobs up there. And so we'll talk a little bit about these differences and when we might use these things in Azure. But to go over some of the high-level concepts on a worker role, if we take a look at the architecture of this would be something like this. So we have an application here, and this application has a worker role that's running inside of it. And so I'll just put a little, that's my gear for my worker role. But essentially what happens inside of this worker role is we just have a big loop. So this loop is going to do something. It's going to execute some code. So there'll be some code that's going to run, and then it's going to wait, and then there's going to be some more code to run. So it's going to basically just keep doing this over and over. Any game programmers out here, we have game loops, similar concept. But when we have a Windows service, this fits the exact same mold as it. A Windows service does the same thing. We start it up, it processes some input, it waits for more input, and it either goes to sleep or continues processing. Now, these worker rules, you want to make sure that these loops don't get too tight, so we obviously have a wait in there that we're going to do. But one of the things, the patterns that come out of this, and I'll draw this out here, is a competing consumer pattern. So if we have something like a queue over here, and this is a typical architecture for an application that's going to do back-end processing. So over here we would have our worker role, so we'll call this the WR, and he just has some code that's going to keep looping, like we mentioned before. And then over here we have a bunch of messages, right? So we get all these messages in our queue. And these messages, what's happening is this worker role is plugged into this. So let's say this is service bus. This is a service bus queue. So essentially it's just a big queue, and messages are poured into here from somewhere else. This could be a web app or something like that, but this is our input. So he's going to create messages and drop them in the queue. This guy's going to constantly be listening, and this is called the competing consumer. Because what happens here is we just have one role. He's going to go get a message, he's going to process it, and then he's going to remove that from the queue and go on to the next message. But what happens if we start doing this? What happens if we start bringing multiple of these guys in here? Well, now we have competition for messages, right? Because these guys are all going to be looking at them too, and everybody wants to grab the same message. So in a competing consumer model, what we're doing is saying we have to put locks in place. So whenever the worker role goes to grab one of these messages, say grabs this one, worker role 1, and let's call this 2 and 3, worker role 1 grabs this, he's going to put a lock on it. Now that hasn't been removed from the queue at that point, but it's been locked so that these other two can't grab a hold of it. And so that's the way that we kind of lock that and be able to run these long-running processes up there in Azure. Now, to take a step back and let's go into the internals of what's going on inside that worker role. When we run that loop, I told you, we have to make sure that we don't process too fast, right? So let's say over here is our queue, and we'll put the queue in here. And this guy is reaching for messages, but there's nothing there. Now, this is a common thing people run into in Azure, is the worker role will go into an unhealthy state in Azure if we put no delay in there. And the reason it goes into an unhealthy state is because Azure has a probe that's coming into this to make sure this thing is healthy. Remember, this is a PaaS type application, so Azure needs to make sure that the instance is running, is healthy. And the only way he can make sure it's running healthy is he can inject some code in there to say, is everything running okay in here? Well, if the CPU over here is maxed out because this guy is constantly hitting this queue and has no breath, he doesn't wait even a millisecond in between those, this guy will go into an unhealthy state, Azure will spin up another instance. He'll go over here, spin up another worker role, and kill this guy, even though there was nothing wrong with him. So the important point to remember here in your architecture is when you're designing long-running applications is make sure that you have some implicit delay built into the system. We can't have these things go instantly because otherwise we cause unhealthy states in Azure. Now, one of the things to mention with autoscale, and a case scenario that I ran into, was a customer had to need this. So they had this scenario. So they had a bunch of on-premises services, and these were Windows services. Everyone was the same. Now, these would run constantly, but they would only run a certain time of the month. Let's say the last Friday of the month, for argument's sake. And what they would do is all of these services would reach out to a bunch of BizTalk servers. So we had a BizTalk infrastructure here, and basically had a bunch of WCF services here. And so what would happen is we would get a bunch of messages for these guys to process, and they would call in. So there would be some input into this. There would be a lot of messages coming in here at one point. And these guys would see those messages, start processing them, and call out to these WCF services to orchestrate a big business object, a big business workflow. And then the output would be some data over here. Let's just call it in a database, ends up processed messages. Now, this customer came to us and said, how could we run that in Azure? Because basically we put multiple of these on one server over here, and then we have multiple of those. So we have like 3. So let's say we had 9 of these processes running here doing that. How could we run that in Azure? So the approach we took was to say, okay, let's break this down. Let's take whatever that core logic is right there, and let's port that into a worker rule. Now we just have that one piece of logic to do all the worker rule manipulation, and now we can just spin up 9 instances of it. Or we could spin up 15 instances of it if they wanted. And so what was great about that is we could start to benchmark, and we could actually run their process faster because we didn't have to have all this infrastructure spin up. We could just spin it up when we needed it, which was a perfect use case for autoscale with Azure and PaaS. So this fits perfect, and this is the kind of the model to use when you're working with those.
So am I understanding that correctly when you're talking about you had one of those that you did as a worker role, essentially you can kind of clone them?
Yeah, exactly. So once we have the configuration, this only is defined once. We can just replicate that by literally dragging a slider in the portal or using a script to do it.
It saves a ton of work.
So yeah, it was a great use case for a long-running process that runs in the background. That one happened to be a really spiky workload where it only ran at certain times, so they were able to save a lot on compute because those weren't sitting there idle all the time. And so that concludes the module on the topic of long-running applications in Azure.